I want to demonstrate kind of a sensor fusion application, which is indoor positioning, or consider a robot. I want to trace the robot or track the robot. Or if I'm a vacuum cleaner, I want to go back. If I'm an autonomous drone, I want to maybe fly and then go back to wherever my launch point. So here's the demonstration. This is an app. Actually, this graduate student of mine have wrote that. And it uses the 3D camera, as we've seen before. It uses the regular camera. It detects the movement as if it was an optical flow. But it also associates those feature points as seen in the Booth CV. Another smart thing, it understands the orientation of the phone, both from interpreting the IMU, the inertial measurement unit, but also the video. Just by detecting those pixels and understanding my movement and understanding that when I go closer to an object, it inflates or it gets bigger, allows me to perform 30 Hertz indoor positioning. And let's demonstrate that. So again, as we always do, I'm going to use the chair and I'm starting the app. It looks like that. So now I'm in the, you see the compass, you see me moving. Let's zoom in a little bit and let's do that. Okay, this is as close to a perfect circle as I could do. We'll do it a few more times till I'll get a little bit seasick. But the idea is that what you see here is something which is quite amazing in terms of accuracy. So my entire movement was less than a meter. I could actually draw something. Let's zoom in a little bit. And this draws my position. And although I've been moving a lot and talking a lot and maybe rotating the phone, the green dot where I started here is only about, let me compute it. Okay, a few centimeters, like 7 centimeters away and 50 centimeters on Z and 6 centimeters. So although I moved quite a lot, very few, the drift is minor. And using this system, we've been able to do indoor position in many competitions and many like university researches, and go down to below 1% drift. And an interesting algorithm, which I'm going to demonstrate soon with my computer, is that having an optical flow or enhanced optical flow, as shown in this Tango phone, allows me to let me walk while doing it. So it allows me to perform an accurate, so let's do an 8. So although we're in a green room with almost no feature points, it allowed me to track my position to an accurate manner. So the next level will be, okay, I'm able to track. I'm below 1 or 2% drift, but still I'm drifting. So the next level will be to be able to detect that this location I'm already been there, or perform SLAM again, meaning simultaneous localization and mapping. So using the low drift mapping and the 3D geometry of the camera, I can gain a sort of geometry. And using this geometry, I can perform further positioning or localize myself within the room. And in a continuous manner, I could be able to fix this 1% or 2% drift towards a place where there's almost no drift. And this sounds extremely complicated, but in reality, this is actually what's being performed by your vacuum cleaner at home. And in the next section, we're going to understand how this tiny little camera, and demonstrate, the one above here, is performing that actually both the stereo, the interpolation, and the SLAM algorithm on board. So it could the entire thing could be done in this little I don't know, like a chocolate bar wrapping of two cameras.